Hello again, this is Andrew Sheets, and for this video is my more in-depth breakdown of the code that was created. So here, for the wolf locomotion, you can see that depending on where the wolf moves, it can go left or right smoothly, and then it go from walking to running, and vice versa, all that jazz. The main thing with this root motion setup here is that I had a lot of issues with the model. Had a lot of jitter when we were using this root motion, so I had to modify different values, such as the the minimum axis value and the maximum axis value, along with stuff like the interpolation time and several other values in here, some of which through trial and error, but eventually I got to the point where it would move smoothly like it does in here, as you can see in the first couple of videos. So that was good. And then this is just part of the animation blueprint. And then let's see, this is the behavior tree for the AI wolves. So we'll start with the patrol, because that is what actually the wolves will begin doing, since these first ones will be ignored because no target has been set, the player has not been found, so we'll go to the patrol sequence here. So it starts with an EQS query. So basically, this just gets the area around the wolf, and then it determines what's around the wolf, and it will determine based what is set up in here through several different values, where would be the most appropriate place for it to go. So is there a wall in the way, then that would have a lower value than, say, a value that is ahead of the wolf where there is no wall. And of course, this will be changed depending on where they are in the world, if there's a corner or not. So let's see. Yeah, so basically it just sets up where the wolf will go, and then what happens next before it goes there is that it moves to the leader or alpha wolf. So the alpha wolf has been set by the developer beforehand, and it will, if it's not the leader wolf, then they will move to the leader wolf. But if it is the leader wolf, then it will move to this patrol location that was set by the EQS query. Now, assuming that the player has been found finally, we're going to remove this for now. The target will have been set. Now, it will not go to this because this is a selector. It will go to the first node before it that works and that doesn't fail. So here in this sequence, you see that this howl task will be fired. So assuming that the has howled variable that is set in the blackboard is not set, then it will continue on. And then that variable is set to, it is set after this is played once. So that way it will not continue to howl after it has howled once. And this cooldown is just for, like, maybe in the future if I want the player to be able to lose the wolves, and then after they've lost them for a certain amount of time, then they can howl again if they see the player again. So they will howl using this task, and this task is basically just, well, I suppose it start, let's see. Start with a blueprint interface, basically just creates a very simple function that we can use, and then this, let's see, where is it? Here we go. This event will become set to where when this event is called, it will play an animation montage, the Howling Wolf. They can be added on stuff here, like maybe damage or whatnot, but for the purposes of this, this is just an animation montage. So it will play this animation in this task over here. So on event receive execute AI basically just means that whenever this has been fired, then this code will play. So basically, it calls the howl, so the animation montage will play. This sets has howled, and it sets this key so you can see in here has howled is false. Well, it also has howled 1 in here, so it can determine if it was set or not. Where is it? it is here. Sorry. So, additionally, it sets the blackboard value as a boolean so that it can determine whether it's true or false. And here we cast the NPC2 character, which is the wolf AI. We set his howler as well, and make it the literal name, and finish execute. Let's see. So, assuming this goes through, the is howler is howler I will go through in a second, but essentially this alerts the other wolves to is the wolf's presence. This plays the animation, and then it will wait 3 seconds so that it can play the animation without moving in the patrol. So once this animation is played, and some of the variables have been set, then this other task, move to is howler, will be called. Is howler is a variable that determines which wolf has seen the player, and as you can see here, the instance synced has been turned on so that all the different wolves all know that this variable has been checked. So they all know who the wolf that howled is. So they will go to that wolf, and once they go to the wolf, they will naturally see the player. And once they see the player, they will chase the player. Now, the there is, let's see, they will not. What I'm trying to say is basically that they will branch off and just break off from any of these, like move to leader, move to patrol location, move to howler. They will all break off of this if they see the player. If they see the player, of course they will howl, but if one has already howled, the others will not howl. They will just locate the one that did howl until this cooldown. This cooldown has stopped. But I haven't done it. Anyway, so here we see the actual attack sequence. So in this attack sequence, assuming that the target actor has been set, which is the player, then this conditional loop will also play, which means that as long as the target actor is set, then this attack sequence will loop essentially. So it goes first into task alert, and task alert basically just runs off of, let's see, it starts here with the AI perception, that is a component that is added to this AI controller that is attached to the NPC character. So essentially, this perception, whenever the player is put in front of it, because it, let's see, has this interface where it determines that is target is true, which means that the first person character is the target that they should be trying to find, then they will first determine that this is the player, that this is the target, and if that is true, then they will set the blackboard value target actor, making the player character the target actor that we see in the baby tree. So first sets the sets it as that, and then we go back to the actual task to right here, and then assuming that the task alert has been called. I apologize, 1 second. There we go. So assuming that has been called, then the controlled pawn, meaning the AI wolf, will move to the set blackboard key, which will be the target actor, of course. So they will move to the target actor through the set blackboard key, and then they'll finish the execute, of course. And going back here, this will go to the attack task. The attack task is just a modified version of the howl task, meaning that it's basically just an animation montage that plays. Once the AI has successfully moved to the player, then it will play the animation montage. I can add like damage later, but this for right now just plays the animation montage. It will wait a couple seconds so it doesn't play it repeatedly, so it just looks a bit more functional. And it will continue to do this until the player has been caught, essentially, or killed, run out of health points when I set that up later. So that's basically the AI here. The only thing that wasn't present here before was the AI move to leader, but I modified this so it could work in the AI wolves as well, rather than just the character that was intended for originally. Let's see. We'll then go to the final thing here, which is the scan effect that you saw. So basically, the main thing here is that I created an instance, and here I just made it easier for designers. So you can modify just how it looks on the fly. And here, which is probably the best part of it, the this changes the colors of the different stencil depths, basically. So depending on what value it is set to, it will have a different color. And here you can set each of those colors in this instance, rather than having to go in and individually do it in like the scan effect. So essentially, maybe if you have so here we have it set to 2 would be red. So we'd have the custom stencil depth of 2 be red, and you would apply that to each of the enemy wolves, so that when the scan effect is called, which you can see here, basically when F is pressed, this timeline will be fired, which basically increases the radius of the sphere, and then once that has been finished, it will set it back to 0. So that will be played, and then it will assign this color to the AI, well, what it has been assigned to, which is the wolves currently. And this will be assigned to anything with the custom stencil depth of 1, and this one, the custom stencil depth of 2. So you can just do that on the fly here. So maybe you don't want the enemies to be red, maybe purple, or you don't want the objects to be blue, you want them to be green or something. Then you can just do that from here. And you can also change the size of like how far it would go, or maybe just how bright the colors would be. Just easy for designers here. So that's pretty much it here. Let's see. I'll just quickly go over the create sphere here. I changed the these material parameters so that we can use them in the actual instance. So yeah, basically it just gets the camera position. It uses the collection parameter, multiplies it by the radius, and then it just has sphere mask. And through some multiplies and lerps, several lerps that go with these, which determine the they set up different custom stencil depths. So basically 1 and 2. Let's see. And then that goes into here, and you can have the emissive color as it expands with the stuff that I showed you in here. So that'll be it. Thank you for watching.